Hello, and welcome back to Baxter Breaks It Down. In this episode, we're going to look at power functions and their applications. In our previous episode, we talked about variation, right? We had direct variation, inverse variation, joint variation. So whenever like they use the phrasing that like y varies directly as x, I'm going to write y equals k times x. Okay, y varies inversely as x. I'm going to have y equals k divided by x. And jointly, I could have like y varies directly as x and z, or like I guess would use the word joint. So y varies jointly as x and z. So I'd have y equals k times x times z, right? So we're just going to take that one step further. Yeah, that's all we're going to do. Let's just take it one step further, okay? You can write those power function variation equations. That's the first step. That's what you need, okay? So applications involving variations. In a variation problem, we don't know the value of k, that constant of proportionality. And so we're going to find it, right? We're going to start by writing that power function equation using k as our constant. Then we're going to substitute the given values in for the variables and find k, and then we'll be able to write a very specific equation, like a formula, using step one and our constant of proportionality. So it's actually really easy, okay? In fact, everything is grouped together nicely in these problems, so you don't have to go like searching for all the information or organize it later. Like that's not necessary, okay? Everything's going to be given to you. In fact, I'll like, you see where that semicolon is? So I'll just like put a squiggly there, put a squiggly here. So basically, just take this one step at a time. Everything is chunked. The very first chunk that you're going to get gives you your initial equation. So my strategy for dealing with the initial equation is to highlight stuff, write the equation after you read it. So it says y varies jointly as x and z. So y jointly x, z. Got it? Okay, side right, y equals, since it's jointly, that's k times x and z. So y equals k times x times z. That's step one, writing the equation. Step two, let's substitute the given values into that equation. So they gave us that y is 25 when x is 2 and z is 5, right? So I'm just going to take this. I'm going to substitute all my values in. So y is 25. So 25 equals k times x is 2 times z is 5. So 2 times 5, well, that's 10. So 25 is equal to 10 times k. And so that means k is equal to 2.5. So that means my new equation is a combination of my initial equation. I'm just going to put the constant value in, and I get y equals 2.5 times x times z. See, I told you, it's pretty easy, right? Let's try another one. This one's going to take us one more step. That's right. Yeah, I just keep going. But everything is grouped together. Okay, so we just need to read as far as the initial equation, and then we'll stop. So the length L in feet of skid distance left by a car varies directly as the square of the initial velocity v in miles per hour. I'm going to stop right there. That is everything I need for my initial equation. I need to write that down before I go any further. So L directly, square, and V. So L equals directly, I write K times, because that's what I'm using for direct. And they say square of V. So V squared, that's what our equation looks like. So now I'm ready for that constant of proportionality. So let's get our info. A car traveling at 40 miles per hour leaves a skid distance of 40 feet. So L is the skid distance. The 40 miles per hour is the velocity. Okay, so I'm going to plug those things in. So I've got the skid distance of 40 is equal to k times the velocity, and that was 40 as well. So I'm looking at 40 is equal to k times 1600, and then I should really divide that, and I did. So I got k is 0.25. And then your new equation is simply the initial equation with k written in. So L equals 0.025 times b squared. All right, so that leads us to that very last item, the solution, okay? So this all comes from the question that's being asked at the very end of this problem, and that question is, determine the length of the skid distance left by a car traveling 60 miles per hour. That's 60 miles per hour, that's a velocity. So I simply need you to just plug that in and then calculate my result. So L is going to be equal to 0.025 times 60 squared, right? Throw that into your calculator, and I got 90. So 90 feet is the skid distance. Okay, but everything is like chunked together. You can just take it piece by piece. You don't even have to read like the whole problem all at once because that would be silly. Just get through that first like sentence or that first chunk of what you need for the initial equation, write it down, continue reading. So let's try one more, okay? So one's intelligence in quotient, which is your IQ, so I, varies directly as the person's mental age, M, and inversely as the person's chronological age, C. So now it's time for me to stop and write my initial equation. So we have I, varies directly as, so K times M, and inversely as C. Now we're ready to find our constant of proportionality. So it says a person with a mental age of 25 and a chronological age of 20 has an IQ of 125. So we're going to substitute all those values in. So we know that our IQ is 125 equals K times M is 25 and C is 20. Okay. So I can first go and multiply both sides by 20. So 125 times 20 would give me 2,500. So 2,500 is equal to K times 25. So that means K is equal to 100. So now I'm ready to write my new equation. It's just the initial equation with K written in. So I have I equals 100 times M divided by C. That's my new equation. It's a formula. And then I'm using that formula to answer the final question in this problem. What is the chronological age of a person with a mental age of 40 and an IQ of 80? So then it's just a matter of substituting those values in to their proper location. So they told us the IQ is 80. They told us the mental age was 40. And we want to find the chronological age. So I can just do some calculating here. And I get that my chronological age is 50. Okay, but it starts with that initial equation. Then we just substitute what we're given to find K. And then we're using this new equation to answer whatever question they ask us. But it's simple. Really, it is. And that is how Bakker breaks it down.